Here is another example. Here he's asking about find the power consumed or supplied in each element, supplied by each element. So here the first thing is given circuit is in time domain. We need to convert that into frequency domain. Okay, so first important thing, make sure the omega is same. If omega is not same, then we cannot solve it by using either mesh analysis or nodal analysis. Since we have two sources here, we have to solve it either by using mesh or nodal analysis. If omega is different, then we have to solve it by using superposition theorem, which I haven't talked about it, and in this chapter we're not going to talk about it, so don't worry about superposition theorem. So assume that if it is omega is different, then we have to solve it by using superposition theorem. Now our goal is find the power supplied or power consumed by each element. Now next important thing is uh, convert that sine into cos or cos into sine. Make sure both of them have the same sine or cosine. So what I'm going to do here, I'm going to convert this cos into sine. So sine 90 plus theta is cos theta, so I'm going to take this as theta. So to convert this into sine, I just need to do sine 90. So that's what I did. 169.7 cos 2t equal to 169.7 sine 2t plus 90. Okay, I'm going to convert XL into JXL, which is j omega L, j 50 ohms, and this is minus j 50 ohms. So capacitive reactance is converted into minus j 50 ohms. Inductive reactance is also converted into ohms, which is plus j 50 ohms. Now here, make sure convert the voltage into RMS value, so it must be 120 at an angle of 0, 120 at an angle of 0. Once the circuit is in frequency domain, we always take the top one as positive and the bottom one as negative. So same thing for the both sources. Now I'm going to do it by using loop analysis. So loop 1 minus 120 plus 100 I1 minus j50 I1 minus I2 equal to 0. So when I simplify this equation, I have 100 minus j50 I1 plus j50 I2 equal to 120 at an angle of 0. Loop 2, same thing, I'm going in this direction. So j50 I2 plus 120 at an angle of 90 minus j50 I2 minus I1. So after solving this, I end up with j50 I1 equal to minus 120 at an angle of 90. So I end up with I1 equal to minus 2.4 ampere. So my I1 is minus 2.4 ampere. Same way, if I substitute that I1 value into first equation, I end up with I2 equal to minus 2.4. I end up with minus 2.4 minus j 7.2. So this must be minus. So this must be plus. Okay. That must be plus. So minus 2.4 minus j 7.2. I put to take out the minus out, so it is 2.4 plus j 7.2. So now, since both quantities I1 and I2 end up with the negative number, I prefer to deal with positive numbers. So what I did, I changed the direction. So I'm taking this IY instead of I2 going in the opposite direction. So the negative is going to take away. So it's going to be 2.4 plus j 7.2, and the 2.4 is going away. So those are the currents. Now I believe I redraw the circuit diagram here. So here is I 2.4 going away, and 2.4 plus j 7.2 is coming in. So currents going out must be equal to currents coming in. So applied KCL at this point. So 2.4 plus j2 is coming in. So 2.4 is going out. So plus j2 must be go out right there. Now, if you look at the source 1, okay, I'm taking this as source 1. Okay, source 1 power equal to Vi cos theta. V is 120 volt. I is 2.4 ampere. What is the cos theta? What is the angle between these two? This is 2.4 at an angle of 0, 120 at an angle of 0. So angle between V and I is 0 degrees. So it is 288 watt. That's the power. Is it consuming or supplying? Current is entering the positive terminal, so it is consuming. So the source is not supplying power, it is consuming the power. That power is active power since it's P1, and Q1 is 0. it is not consuming any reactive power. Resistor, remember, it always consumes the active power. So that P equal to I square times R, which is 2.4 square times 100, 576 watt. That is also consuming active power. So source 1 is consuming active power, resistor is consuming active power. Resistor never consumes reactive power. Now capacitor, remember, always supply reactive power. So Q equal to I square times XC. I square is 7.2 whole square, XC is 50. So 2592 var. This is supplying. Capacitor always supplies the reactive power. Inductor always consumes the um, inductor always consumes the reactive power. It never consumes active power. So the current passing through that inductor is 2.4 plus j 7.2. Convert that into phasor format. Okay, a phasor format is 7.589. So 7.589 whole square times 50. So it is consuming 2879.69 watt. Now source 2, how much power it is supplying? So source 2 is supplying because the current is leaving, positive current is leaving the positive terminal. So 120 times 7.589. What is the angle between these two? One is 90 degrees, one is 71 degrees. So if you look at it, one is, that's the voltage, that's the current. What's the angle between these two? That is 18.43. That's how I got that 18.43. So that is 863.97 watt it is supplying. And Q equal to 120 times 7.589 times sine 18.43. It is supplying 2870 point let me, no, that's the right number. It's 287.90 var, and that is also supplying. Now we want to verify our supply must be, any closed circuit or power supply must be equal to power consumption. Okay, so this one, source 2 is supplying 863.97, I can say 868, and resistor is consuming 576, and your source 1 is also consuming 288. So altogether it is 860, 864. Okay, and Q must be the same too. So Q supply, the source 2 is supplying 287.9, as well as our capacitor is also supplying 2592. So altogether an inductor is consuming this much var. Okay, our supply must be equal to the consumption. So this is how we will find active, reactive and apparent power in a circuit. Thank you.